Assalamualaikum warahmatullahi wabarakatuh and good morning. Today, my team member and I, Ahmed, Firdaus, Shahmi and Umar will be discussing about the organometallic cluster compounds, borane. So today, we will be discussing about preparation, structures and naming, bonding, and also the reactivity of boranes. So before I going into the preparation of boranes, for your information, free boranes, pH free, is very unstable. Therefore, a higher boranes such as thiboranes and so on are usually synthesized. So, the example of preparation of boranes involve first the exchange reaction, or we call as metathesis of boron halide with lithium aluminum hydride, or we can also use lithium borohydride. So from this equation, 2 moles of diborane can be obtained from this reaction. Next, we can also use the reduction process, reduction reaction of boron 3 halide with hydrogen. So from this equation, we can see that after the reduction process, the boron 3 halides form into become diborane with the addition of hydrogens here. Next, a higher boranes can be obtained by controlled pyrolysis of diboranes in gas phase. For example, in this reaction, a triborane can be obtained and followed by the tetraborane after a further pyrolysis. So, fun fact, diborane burns if it is in contact with air. Therefore, the reaction involving the preparation of boranes has to be done under vacuum, such as using the Schleng line or with exclusion of air. For example, with the pyrolysis method, where it involves the heating with the absence of oxygen.
We continue with structures and name of boranes. For naming, we use letter prefix monoditri, etc. before the borane to indicate number of boron atoms. Immediately following E in borane, we put number of hydrogen atoms in parentheses using Arabic numerals. For example, BH3, we write boron 3, B3H6, diboron 6, B5H11, pentaboron 11. But if we know the structures of the borane, we put it in front of the prefix. For example, arachno-pentaboron 11. For structure, based on the picture, we have 3 basic simple structures, which are chlorosonido and arachno. Chloroso with general formula BNHN2-, it is a case shape, it is a closed polyhedron. For nido, BNHN plus 4, it resembles the structure, it is a polyhedron with 1 vertex removed. For arachno, BNHN plus 6, it resembles a spiderweb structure. It is a polyhedron with 2 vertex removed or have an open face. For Wedge-Rules is used to rationalize the structures of borane by calculating the skeleton electron pair. The summary table is there, as you can see. For example, how to use the Wedge-Rules? We choose B6H6 2-. First, we need to calculate the total number of valence electrons for this compound. It is 26. Then we need to calculate the BH electrons, where BH contribute 2 electrons. So here we got 12. Then we need to find the skeleton electrons, which the substitution of 26 and 12, we got 14. So to find the skeleton electron pair, we divide the 14 by 2 and we got 7. From here, we know that the number of vertices for this structure is 6. So the 7 here will be n plus 1. So here we know that n plus 1 is belong to a closed structure.
Next, I will continue with the bonding. Let's have a look at the boron first. It is located in the group 13, 3 valence electron. To form BH3, like in the picture on the left, it must excited to promote the electron into s orbital into the 2p orbital. So it now form sp2 hybridization, and the boron can form the bond with 3 hydrogen via the overlapping of sp2 orbital of the boron and each s orbital from hydrogen atom. However, BH3 is not stable because it has only 6 valence electron. So to become stable, it must follow the octet rule. Then the borane can be stable by undergoing dimerization, and it becomes diborane. Diborane is formed to make the central boron, which is this one, become octet, which is valence electron is 8. So you might be thinking the drawing of diborane is like this. It is totally wrong because if we count the electron, borane has 3 valence electron and it share 1 electron from the hydrogen. It is 3 plus 1. BH bond contribute 1 electron. So 1, 2, 3, 4. So 4 plus 3 is equal to 7. Also not obeying the octet rule. The structure on the right will make the boron central atom will obeying the octet rule because this half arrow is emphasizing or indicates the donation of bond pair instead of lone pair. So this one, the boron has 3 valence electron. So BH bond is contribute 1 electron. So 3 plus 1, 4, 5, 6. So 6, this half arrow will contribute 2 electron. So 6 plus 2 equal to 8. So this boron already achieved the octet rule. So it becomes more stable. This is called 3 center 2 electron bonds, which is there are 3 atoms, which is B, H, and B, is sharing 2 electron, which is originated from this one. Next, I will pass to Ahmed.
Hello. Now I'm going to talk about the reactivity. So we start with the reactivity trends. So the boranes are reactive compounds, and the majority uh, are poisonous, and they can require special handling and treatment. So the reactivity trends for the three types of borane, which is the closo and the nido and the arachno. So the first one, they are different with each other because of the skeleton bonding of the electron pair. So the first one, the skeleton bonding is N plus 1 and N plus 2 and N plus 3 for the three types of the boranes. So the first one, which is the closo, there is no known neutral structure or neutral compound of closo-borane, but the salt of the closo ions are stable in neutral aqueous solution, and their stability can be increased with the size if the size is increased. So the nido, we have the benta and the deca borane, which are the most stable of the nido boranes. And for the last one, they are the more reactive than the nido, but and they're also, and again, they're the larger it or the more size of the compound of the borane, the more stable it will be. So we're gonna look for some reaction. So the first is the reaction with the Lewis spaces. So boranes will be cleavage by the can be cleavage by the nucleophiles, and it can be cleavage by two ways. So we have symmetrical and unsymmetrical, the bridge for the bridge cleavage. So usually using neutral bases, the two cleavage will make two types, which is molecular and ionic fragments. And these fragments can also be used or for further reaction to be substituted in substituted Lewis space reaction. So the second one, we have the proton abstraction. So we have the protonation of the hydrogen at the bridge position, which give us yellow species, we have this example of the proton 10 with 14 hydrogen, and we have the protonation of the hydrogen at the bridge position in the middle to give us 13 hydrogens. And lastly, there are many types of reaction of the boranes, but because of time, we explain the first one and the second one. We have also cluster building reaction of borohydrase and reaction of nidoborane with an alkyne to give a carbonic cluster. And lastly, this is our reference. And thank you very much, everyone.